Now, so we start with this questions. And I'm just gonna give you like a very fast breakdown of how this question going. Um, so first part, you guys have no problem, right? The first part, the result, we should get a -7 over 12 feet per second. Now, we're gonna use for part B. The reason why we need to use for part B is you need it. Okay, so let's look at the part B. Part B says consider triangle formed on the side of the house, the ladder and the ground. Find the rate of changing area the triangle is changing when base of ladder is 7 feet from the wall. So they are looking for this area right here, right? So I'm gonna draw out the ladder on a different plane, and I'm gonna have a ladder here. Oops. And this ladder is 25, and this is 7, and this is 2 feet per second. And they say, hey, can you find out this area, the triangle? But the area of triangle, so we know that dx dt is equal to 2 feet per second. Now we also know relationships area is equal to 1/2 base times height, which is base in this case is x times y. Is that okay? Now I can take a derivative with respect to time, and I'm going to get dA dt. Is this okay? That where does the product rule? Do you see a product rule? Because the x times y. Now, you have product rule, you got to make sure you take a derivative with respect to time, so it'll be dx dt times y plus x dy dt. Is that okay? Am I going too fast? And they are looking for dA dt because dA dt is unknown. They say how fast the area is changing. And then you say dA dt when the x equal to 7. When x equal to 7, y is equal to 24. So we already have all the information. Now I'm just worried about plugging in. So they say x equal to 7, y equal to 24. You can write it like this, which is now you know what to plug in. So 1/2 dx dt is 2 times y, I don't know, 24 I think, plus x, which is 7, and dy dt is -12, -7 over 12, according to previous question. And then all you gotta do is evaluate this, and you get an answer, whatever that combined fraction is going to be, that is gonna be the key. Now we kind of did that yesterday. There was a question about a triangle that you had to do a product rule. I didn't tell you to do that, but some of you guys figured out a way to do it, which is great. But that's not something I'm focusing on today. Something I'm focusing on is part C. 24 plus 7 times -7 over 12. I just plug in all the information. Can I go to the next part? No? Okay, I'll wait for you. Not all the time you had to do product rule. This is the one situation you had to do product rule. And Monday Tuesday we're gonna teach you how to avoid product rules on the comb questions, and also we're gonna talk about the shadow question, the infamous shadow question that everybody is discussing about. If you're really advanced, you can also do some crazy shadow questions, but we're not there yet. With that being said, let's go look at the part C. Let's read the part C together. Anybody a good reader? Want to read it? Or you want to read it silently? Jack, look like you're a good reader. You want to read it? You're dyslexic? All of a sudden you're dyslexic. Are you serious? No, you're such a liar. Jack doesn't have a good poker face. I can't read, you know me. Okay, Madeline, you want to read it?
Find the rate at which the angle between the ladder and the wall of the house is changing when the base of the ladder is 7 feet from the wall.
Okay. So which angle are they talking about? They talk about the angle on the top or the angle on the bottom? Yep, it should be the top. So let's redraw this. And I'm going to erase this part because I don't need this part anymore. And if you need, just take a picture of that. That's fine. But I'm going to get rid of, okay? So this is the angle they are interested about. And they want to find now how fast the angle is changing. Now, the angle changing is going to become greater, or it's going to be positive or negative if I ladder sliding down. Positive. The angle is going to get bigger, right? So hopefully your answer is positive. If your answer is negative, it means you did something wrong. Okay, so now I'm going to talk about this phrase right here. They say which angle is changing. That just means d theta dt. So this means d theta dt. And also they talk about specific angle, so they are angle on the top. Any questions? But everything else stay the same. Bottom 7 feet, the dx dt is that. So anytime you have deal with changing of angle over changing of time, you want to think about SOHCAHTOA. That's the only time you have to think about SOHCAHTOA. So there's a changing of angle over changing of time. If that just means d theta dt. You want to think about SOHCAHTOA because only SOHCAHTOA can give you an angle. I mean, there's other situation. You can have log sine or log cosine, but we're not going to go through that because that's going to be too complicated. So we're going to stick with something that just really basic trigonometry. SOHCAHTOA, you learn it in geometry. So sine theta equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. And tangent theta is equal to opposite over adjacent. Now, here's what I want you to write down in red. Make sure constant on the bottom of trig ratio. Constant means what? What is a constant in this case? What doesn't change? The length of ladder. So it's 25. So you can choose, make sure the constant's on the bottom. So the only two options viable in here is which one? Sine and cosine. But now I'm going to make sure I'm using dx dt rather than dy dt. Because dy dt we got. It's a negative 7 over 12. But again, is we get to do our calculation. What happens if our calculation is wrong? Then your answer will be wrong. So you want to be independent from your answer that you're getting. So you prefer to use the x. In this case, what will be the perfect trig ratio to set up? That have opposite or adjacent or hypotenuse. Which two things I want to deal with?
It would probably be sine because it's opposite and hypotenuse, and those are the two that it gives you.
7 over 25.
Okay. So
I did no.
which trig ratio that you want to use?
Sine.
If everybody agrees sine? Okay, let's do a sine. Sine is good. There's two reasons why it's good. Is the hypotenuse is 25, which is constant on the bottom. X is on the top. Why x? Because it's opposite from the theta. You know sine theta usually is y over h. but in this case, relevant to this, this is the opposite. Does that make sense? Now I'm going to take a derivative. Respect to time. What's derivative of sine theta? Yes, hold on, madam.
Why did you put 7 in for x?
Because 7 is constantly changing. If everything that's changing, you do not put in. Everything's constant, doesn't change, that's the only time you put a number. 7 still increasing, and 24 is decreasing. So, but 25 never changed, so you got 25. Good question, great question. That actually a very important question. Now, if I take a derivative with respect to time here, what am I going to get on the left-hand side? Be careful.
Cosine theta, right?
No, more than that. Yeah.
Cosine theta d theta over dt.
Remember, there are two layers, right? So that's going to be cosine of theta and the d theta dt. And that's equal to 1 over 25 dx dt, because there is also x. You have to take a derivative with respect to time. Am I going too fast? Maddie, am I going too fast? You're going to be, I don't get it. So in my class, if you all focus for like a second, then it's kind of like, what happened? So what I'm gonna do is I'm gonna divide it by cosine on both sides. So it'll be 1 over cosine theta. Does that make sense? I just divided by cosine. So cosine moved to the denominator. I'll even change that to dx dt is 2. And I'll change that to secant of theta. Does that make sense? Because 1 over cosine is equal to secant. What do you know about secant? Is gonna be hypotenuse over what? Adjacent, right? So 1 over 25 times 2. What is hypotenuse in this case? 25, good. What is adjacent in this case? It's the y, actually. Which is we get from before, y is, if this is 7, this is 24 because we're using Pythagorean identity. So that's 24. Is that okay? $25 will cross it out, and that's going to be 2 over 24, and that's equal to 1 over 12. And then 1 over 12 is going to be radian per second. Now, some people say, what is radian? 1 radian is what? How many degrees 1 radian? Thank you, Chase. 57.3 degrees. So 1 over 12 of that is roughly divided by 12. So if I have 60 divided by 12 is roughly 5. So somewhere between 4 to 5 degrees. It's 4 to 5 degrees per second, which kind of makes sense. If the ladder's lying down 4 to 5 degrees, it sounds pretty reasonable. Yes?
Where did you get the 2 from?
Where did I get to? That's a dx dt. That's how fast I'm pulling away the bottom of the ladder. It's the same questions as before.
Okay.
Wait, how much is 1 radian? 57.3?
Yep. So 1/12 of that is divided by 12. How much time we have?
7 minutes.
17 minutes.
I have 17 minutes or 7 minutes?
17.
17.
Oh, some people cannot count. I'm just kidding. I know. So long as Kelly doesn't come in the room, don't make me nervous. Every time she come in, it's like I gotta rush. And but yeah, so here you got 1 over 12 radian per second. So I'm gonna show you a question. I'm gonna show you a question that involved with this one. Okay, so there's a part A and part B. Part A is what you learned yesterday. Yeah. Part B is something I'm interested in today. So let's see if you can finish in 10 minutes. And I'll go over. Now you gotta figure out what is constant. Guys, talk about what is constant in this case. That's the first thing you should talk about. Okay, so I think hold on, let me take a picture of this post on the things because some people cannot see it. So I'm gonna post I'm gonna post on my iPad so that way people at home they can see this.
Where are you sending it?
Sending it to myself. Okay, so I'm gonna upload it to my Notability, and I'm gonna work to there. Import done. Okay, so here's a question. You cannot read what? No, you can take just take a picture of it. We are care about part B. You could do part A too if you want it. But that's not that hard. We only focus on B right now. But you can do for finish part B, you can go back to do part A.
Okay.
But you need a part A information. You need an 800 feet per second. But talk about what is constant though. What is something that doesn't change?
That one and five being the rocket circumstance and then being squared.
No, but it's something to.
So like that.
Yeah, so it should be a really profile line. Like this big tangent.
He doesn't really have an accent. He's way lower.
Well, you want to find the angle changing. So I think he used tangents because you have no, you have.
Because you have 3,000, right?
I don't think
Without
three-
Jason.
Yeah, I'm wrong. I think it's.
And then the angle is dealing with this.
Yeah.
Oh.
So are we trying to work with the
No, I think you're right. You have to use the adjacent, not for that. It's for that it's changing. So here with cosine. Cosine
I don't think cosine data is good.
It's not cosine? So what's gonna be? Okay, it's made. So 3,000 given, but we don't need the 3,000. We want to see how much is going up, not all. Which makes sense. So it would be tangent theta is equal to the hypotenuse at that time, and then, but no, we're using,
Make the constant
yeah,
the constant is 3,000.
no, but that wouldn't be a constant. Yeah, I'm gonna treat it as, cause we don't.
What time we get up there?
We don't need to do that. That's not gonna tell us anything.
You guys have 3 more minutes. Figure out. I like that attitude. I was telling everybody, my favorite cartoon for kids is like Magic School Bus. Yeah, Miss Fizzle, my favorite teacher.
But wouldn't it be whatever times we want over? Over 5,000. Over 5,000.
Man, he's still sleepy.
Oh, yeah, you.
Still sleepy. You know how like a time change, like winter solstice. That's when you like, yeah. Every time you wake up, it's getting like darker and darker now. And then now you just get really tired when you wake up. Like usually you, in summertime you wake up, it's like very bright. And your internal clock is be like, okay, that's ready to go. But now that you wake up, it's like still dark. You want to go to bed.
Radiant degrees like times 180, or is it 1?
You're all right.
When Kelly comes, she's gonna ask me for it.
Oh, I gotta go. Oh, that's you're doing part A. I'm more interested about part B, but DBDT, so this is gonna be 0. Because that's not changing.
I get it, Mr. Yesterday I was sitting on my bed and I was thinking about it, summation. And I was like, why does it not make sense? And then I just thought about it. And then it clicked. Billy brought me the first shirt.
DP game football. They're gonna get destroyed.
We're gonna get no, yeah, they're gonna get twice.
No, we're gonna get destroyed.
No, Mr. Ye. Gonna ruin my bunch. We're gonna.
They only won last year, right? That's like the last 30 years. They only won one time.
We thought we were gonna get shit out by ourselves.
You got it.
You don't look like a person who watch football though.
Made fun of my friends. My
All right. So now what we're gonna do is we're gonna focus on part B, and then we're gonna go back to part A. So they say how fast the angle of changing. This one is the angle. This one's the angle right here. Oops.
still keep my head.
So this is the angle, right? Now what doesn't change? What's the constant?
3,000.
It's the 3000 that doesn't change. Good. This is the constant. This is your best friend right here. And this is the y, because this is changing, that's why I put down y. But we do have a dy dt. What is dy dt here?
800.
dy dt is equal to 800 and a feet per second. So feet per second, write it down. Now we got all the information we need. What is the trig ratio I should use here?
3, 4, 5. Oh,
Tangent of theta. Because you're going to get y over 3000. Am I doing okay? And I'm going to take a derivative with respect to time. So what's the derivative of the tangent? Secant squared theta d theta dt 1 over 3000 dy dt. Now I'm gonna go into d theta dt. I'm gonna evaluate for that, so it'll be 1 over 3000, and that's gonna be dy dt, which is 800 times by cosine theta. Is that cosine square theta? Why is cosine square? Because you divided by secant square, you can change to cosine square. Is that okay? Yeah, just become cosine square because you divide by both sides. This is 1 over secant square. It becomes cosine square. Is that okay? And that's going to be 1 over 3000. dy dt is 800, I believe. And cosine square theta is 345 triangle. So this is 4000 and this is 5000. So that is going to be 3000 over 5000, I think.
Yeah.
Square. Which is that all the zero just cancel out. And this zero just cancel out. And this one's going to become 4 and 15. So it'll be 4 over 15, I think.
Yeah.
Times by 3 over 5 square.
Yeah.
So that is equal to
So that's 9 to 25.
4 over 15 times 9 over 25, which is, I can simplify this, is 3, this is 5. And that's 12 over 125.
Yeah.
12 over 125 radian per, I don't know, per second. Yeah, radian per second. So that's about 1/10 of radians. And 1/10 of radians roughly is also about 4 to 5 degrees. What? Okay, then I'm gonna go over part A. Part A is gonna be x. No, it'll be not x. It'll be 3000 square plus y square equal to the z square. So if you take a derivative with respect to time, it's gonna be 2y dy dt, I think, plus 2z dz dt. We're trying to find out camera and rocket is dz dt. So 2y, y is what? 4000, I think? And dy dt is what? 800?
Yeah.
And equal to 2z is 5000, I think? And dz dt. So I can went back to evaluate this. I can say, well, we can cancel out the zeros and the zeros. So that's going to be 2 times 4 times 800 over 10 dz dt. And then that's going to give you 1 0 here. So dz dt is going to be 640 feet per second. So, and there you go. This is going to be the camera that's moving at that speed. So 640 here.
yesterday, I thought you were like being gibberish. Now I get it.
Okay.
It's like n is kind of like the amount of rectangles, right? It's approaching infinity, so it's like.
Big brain right there.
Bro, I was like, why is it one? I did it. It's like a unit.
It's a number that it's a series of units. And so eventually you reach infinity. DP games are here or DP? I put my EMF sign out there. I'll be holding a sign. Honestly, like DP's calculus students are struggling so much.
It's on the table. Hey, look at a football. And you make a word problem. Find a derivative. How fast the football is.
True.
Find the table.